अच्छा, तो ये वाला पार्ट जो है ना वो ऑलमोस्ट डन है कि वी लर्नड कि इसके अंदर ना वी लर्नड दैट अच्छा, वी व्हाट वी लर्नड वाज कि phenols of phenylamine, the electron density is very high, ठीक है, at positions 2, 4 and 6, so which is why the electrophiles are very strongly attracted to it, ठीक है, so the reactions are very vigorous. और फिर what would happen is कि since the reactions are very vigorous, you have a lot milder conditions. तो आपका ना ये you just need Br2 aqueous, you don't need a catalyst, and the groups will get attached to all three positions. एक तो ये था. Same with nitration. So that was bromination, and this one is nitration. तो nitration ऊपर लिख भी दूं. अच्छा, this one was nitration. तो nitration के अंदर भी you had a lot milder conditions. And this is halogenation. So this one is halogenation. Anyways, अच्छा ये आपका हो गया this part, ठीक है. Now the next part is okay, there's another thing called 3,5 directing groups. वो इसका ना exact opposite है. So 3,5 directing groups are 3,5 directing.
सर ये आप अब नया पढ़ा रहे हैं?
हाँ, नहीं actually उसी से linked है electrophilic substitution से ही. अच्छा, so 3,5 directing groups. अच्छा, what happens in 3,5 directing groups is कि you have a benzene, ठीक है, you take a benzene, और इस दफा ना the benzene has electron, it's because of electron withdrawing groups. So you have electron, so you've got electron withdrawing groups. और वो यहाँ पे ना electron withdrawing groups, we've already mentioned some electron withdrawing groups जो कि यहाँ पे है, ठीक है. These are called three directing groups. 3 and 5 are the same position. So NO2, NH3, CN, aldehydes, ketones, carboxylic acids, TK, these are all electron. So these are all electron withdrawing groups. Okay, they're electronegative atoms, and they usually end up withdrawing electrons. So aldehydes, carboxylic acids.
सर
हाँ जी.
सर तो लाइक ये दो दो डिस्टिंक्ट ग्रुप्स है ना, एक इलेक्ट्रॉन डोनेटिंग और एक इलेक्ट्रॉन विथड्रॉइंग वाला.
हाँ.
हाँ.
इसके अलावा कौन सा था? Just a second. A CN भी है, ठीक है. There's one more which is CN. So they all have they're electronegative atoms, and they would withdraw electrons. So if you have benzene, उसको अगर आप ड्रॉ करते हो, तो if there's an electron withdrawing group attached to it, ठीक है, let's say there's an aldehyde that's attached to it, तो net result होगा, the electrons are going to be attracted because oxygen is an electronegative atom. The net result would be that the electrons are going to get withdrawn away. तो अब जिन positions पे ना the electron density was actually higher, on the same positions the electron density would actually be lower. कि यहाँ पे ना benzene electron cloud would actually be less dense because the electrons are getting withdrawn. And वो बाकी side से ना electrons are going to be withdrawn as well towards the right. There's going to be a net effect. So the electron density would also become lower at the extreme left as well. So it's exactly the same thing. So electron donating tha, वहाँ पे electron withdrawing with the electron density would become lesser on this side. And the net effect is that since there's an atom over here that's withdrawing electrons, so the whole electron cloud shifts slightly to the right. So this position over here, it has lower electron density as well. Now, as a result, what happens is, relatively speaking, electron density actually becomes higher at positions number 3 and at positions number 5. ठीक है, वो actually in positions के ऊपर it becomes relatively higher.
सर
हाँ,
सर ये 3 और 5 जो है इसके अंदर लाइक कोई प्रेसिडेंस ग्रुप होगी, लाइक इसको लाइक कैसे आइडेंटिफाई करें कौन से साइड से 3 और 5 आएगा?
नहीं जो भी ग्रुप हटाया सो साइड से ना, नहीं एल्डिहाइड है ना इलेक्ट्रॉन विड्रॉइंग ग्रुप, इधर से काउंट करो ना 3 5.
हाँ सर, लाइक वो स्विच हो सकते हैं, मैं ये कह रहा था कि 3 5 के साथ 5 3 के साथ।
अच्छा वो, हाँ वो इट डजंट मैटर, इसे तो वो 3 लिखा हुआ है ना एक्चुअली 3 3 5 नहीं, इट्स जस्ट 3 डायरेक्टिंग 5 को I'll just put 5 in brackets. ठीक है, अच्छा so relatively high electron density at positions 3 and 5. 5 होता भी होगा अगर वो 5 के ऊपर कुछ होगा, अगर दोनों पे कुछ होगा, otherwise just the 3 position. अच्छा now overall मुझे बताओ, overall what happens is the benzene becomes deactivated. अच्छा overall benzene becomes deactivated. Electron density overall in benzene pi electron cloud is a lot lesser. So overall benzene becomes deactivated. Electron density in benzene pi electron cloud is very less. And so reactions जो है ना, less attraction for electrophiles overall. जब donate हो रहे थे ना, what would happen is that the electron density would become higher. And because of the greater negative charge, will Br plus 1 and NO2 plus 1 would be more strongly attracted to it. Now there's going to be less attraction for electrophiles.
सर ये 3 और 5 की वजह से बेंजीन डीएक्टिवेट हो गया?
NO2 इसी ये जो ग्रुप लगा हुआ है यार,
ओके
उससे इलेक्ट्रॉन स्लो रिएक्शंस, ठीक है, उससे इलेक्ट्रॉन डेंसिटी विड्रॉ कर लिया तो यहाँ पे इलेक्ट्रॉन्स कम हो गए, यहाँ पे नेगेटिव चार्ज इज लेसर, इट्स गॉट अ,
हाँ सर।
तो अब इलेक्ट्रोफाइल्स आर नॉट गोइंग टू बी दैट स्ट्रांगली अट्रैक्टेड टू इट. तो अब द नेक्स्ट थिंग इज दैट इसका बस ये, यू डोंट हैव टू गो इनटू डिटेल्स. सो द रिएक्शंस आर गोइंग टू बी वेरी स्लो एंड वेरी difficult to happen. ठीक है, you don't need to know any special conditions for this, but you should know that you would need a catalyst now. Much higher temperatures would be required So there's no specific the basic thing you should know is conditions ko chhod do, because none of those conditions are in your course or syllabus. What you just need to know is, in this case, is ki all you got to know is ki if they tell you about a reaction in which benzene is reacting, it's got a 3,5 directing group. Or let's say वो कह देते हैं कि there's chlorination happening, right? So you should know where to add the electrophile. कि अगर यहाँ पे NO2 है ना, और यहाँ पे there's a reaction of with Br2, right? So I'm just saying ignore the conditions at the moment. ठीक है, the reaction will be difficult, so you would probably need much higher. You'd probably need much higher temperatures, and you would need a catalyst as well. अच्छा, so all you have to do is कि if they tell you to tell them what the product is, so the bromine is probably going to get attached to positions 3 and 3 or 5, which in this case will be exactly the same. So यहाँ पे I'll just add a. Is that clear?
सर
हाँ,
सर इसको नाम क्या देंगे वैसे, मतलब
ये नाइट्रोबेंजीन है, ये this is 3 bromo. NO2 की ज्यादा प्रेसिडेंस होती है, so it's going to be 3 bromo 3 bromo nitrobenzene. That's it. नाइट्रो 1 पे होगा ना.
ओके सर.
अच्छा, इसमें नेमिंग में I'll just tell you one thing के मगर even if I search for this one 3 bromo, अच्छा से 3 bromo nitrobenzene है ना. नहीं, इसका नाम तो एक्चुअली वही है. जस्ट अ सेकंड. मैं वैसे ही बताना चाहता था कि बेंजीन कंपाउंड्स में ना मोस्टली इट्स a lot of times they don't actually use the nomenclature. ठीक है. um, one second. पता नहीं यहाँ पे सारे ने एकदम से नाम. अच्छा, वैसे जैसा मिथाइल बेंजीन है, that's known as toluene. ठीक है. अगर नाइट्रोबेंजीन is known as nitrobenzene. उसका तो मैं वैसे कह रहा हूँ कि they don't normally use nomenclature. Benzene nomenclature is not actually made for benzene, but you can obviously name simple compounds. ठीक है. This is 3 bromo nitrobenzene. Nitro is 1. अच्छा, तो इसके बारे में ना 3,5 के बारे में you don't have to know the specifics. All you have to know is कि भाई reaction मुश्किल होगा, and if there's a reaction, if there's an electrophilic substitution reaction, then the bromine or NO2, ठीक है, even if they do nitration, ठीक है, just ignore the conditions. Just remember the conditions are going to be very tough for the reaction to happen, and you'll get अच्छा, so you'll get another product which is going to be at, so there's going to be one product at, अगर आप nitration कर रहे हो ना, so that
सर और दूसरा HBr बनेगा.
हाँ वो बनेगा. ठीक है, you don't need to learn the conditions, just remember conditions are going to be difficult. ठीक है. अच्छा, okay, anyways, तो इसके बारे में you don't have to know any specifics, just know कि if they ever give you a 3,5 directing group, make sure you put the electrophile in the right position. अच्छा, फिर there's a couple of more reactions which are electrophilic substitution reaction. One of them is called alkylation. अच्छा, अब alkylation is a reaction where you attach a carbon chain or an alkyl chain to benzene.
सर
हाँ जी,
सर आपने वो जो ऊपर वाला था नाइट्रोबेंजीन का सर वो डाइल्यूट नाइट्रिक एसिड
मैंने
मतलब उसको डाइल्यूट नाइट्रिक एसिड से नहीं हो
मैंने कहा एक तो पहली बात एक्सट्रीम कंडीशन चाहिए। मैंने कहा इग्नोर कंडीशंस, इग्नोर करो, छोड़ो कंडीशंस को, वो कोई पढ़ने की जरूरत नहीं है। वो जिस मर्जी से, बस वो है कि एक्सट्रीम कंडीशंस चाहिए होंगी। समझ आई बात?
यस
यानी वो कैटलिस्ट चाहिए था, वो सब इसके अंदर एक्सट्रीम कंडीशंस चाहिए होंगी, क्योंकि रिएक्शन जो है वो स्लो होगा। ठीक है, अच्छा, attach an alkyl chain to benzene. That's what alkylation is. This is also electrophilic substitution, by the way. बल्कि इसका मैकेनिज्म उन्होंने मांगा ही नहीं है, so let's not even write the mechanism. अच्छा, now what happens in this one is कि आपके पास you have benzene. I want to attach a carbon chain to it. ठीक है, इसका mechanism that's not in your course. So I want to attach a carbon chain to this benzene. So what I'm going to do is I'm going to react it with, अच्छा, I'm going to react it with halogenoalkane. So there's H, किसको, so let's make it CH3. So there's a halogen attached, so there's H, and there's Cl, then there is, so for example, this one. Now what will happen in this reaction is कि one of the carbon in this entire chain that's got a positive charge. It's got a slight positive charge. So it's going to behave as an electrophile. It's going to get it's going to get attracted to the electrons in benzene. बल्कि इसको, so this one over here is going to get attracted to the electrons in benzene. Exactly वही reaction होगा. So the carbon will get attracted to the electrons in benzene, and the Cl electrons are going to be knocked out. तो आपको बस ये याद रखना है कि this carbon over here, the one that's in the center, that is the one that's going to go and get attached to the benzene over here. ठीक है, exactly same तरीके से. So but you don't have to worry about how it happens or what's the mechanism. ठीक है, all you need to know is in this case is which of the carbons is going to go and get attached to it. तो आपने जब आप product draw करोगे ना, this is what you're going to do, कि you'll have this benzene. ये उठाया और इन दोनों को ना आपस में जोड़ देना. ठीक है, but you have to connect the right carbon atom, the one that's positive. ठीक है, so you got to attach the right carbon atom to benzene. इस सारी चीजों को हटा देते हैं. अच्छा, ये Cl टूट के अलग हो जाएगा. It would end up forming HCl, and it's this carbon. So I'm going to push the other things out of the way. ये CH3 को उठा के नीचे की तरफ ले आए. ठीक है, so I've bent the CH3, and it's this carbon that's the one that was positively charged. That's the one that's going to go and get attached to this benzene. और खैर eventually positive charge खत्म हो जाएगा. ठीक है, तो it was this carbon over here. वो Cl कहाँ गया? It ended up forming HCl. ठीक है, so you just have to remember this. This is how alkylation will happen. Okay, halogenoalkane is going to go and get attached to benzene. You would need the same catalyst, which is AlCl3 in this case. So that catalyst would be required. ठीक है, is this clear?
सर ये
Yes, sir.
HCl किसी और के साथ बना है या ऊपर वाले H के साथ था?
नहीं, वो H यहाँ से हटता है ना, फिर एक बेंजीन का H जाता है ना.
हाँ, ओके ओके सर।
मतलब वो सब्स्टिट्यूशन में ये होता है ना, इसका जो
हाँ सर, वो पाई इलेक्ट्रॉन क्लाउड के साथ लाइक वो अटैच्ड, वो रिमूव ज्यादा और अटैच्ड।
तो पार्शल हो जाता है इलेक्ट्रॉन क्लाउड, तो वो फिर H से इलेक्ट्रॉन्स वापस खींच लेता है. अच्छा, ये क्लियर है? ये थोड़ा सा ट्रिकी हो
यस सर।
अच्छा, ये थोड़ा सा ट्रिकी हो सकता है इन द सेंस के फॉर एग्जांपल, मतलब आई एम जस्ट गिविंग यू एन एग्जांपल के you get questions like these, like you've got a so let's say you've got a molecule or उसके अंदर ना it looks like this. Okay, it's carbon and then there's a CH2, there's a CH2 and there's a CH3 and there's another CH3. So they might say, okay, name the halogen or halogenoalkane which got attached to benzene, ठीक है? तो रिवर्स में भी हो सकता है. So let's say they already gave you the product. तो आपने ना reagents identify करने हैं. What are the reagents that are needed to make this thing? So this is the compound that we are trying to make, ठीक है? So obviously it's this thing that got attached to it. Or कौन सा carbon got attached? It's the one over here. So the Cl would probably be over here. It's going to be attached to, which made this carbon the positive carbon atom. And that is the reason this was the carbon atom that got attached to it. ठीक है, ये वाला positive carbon atom होगा. So the halogenoalkane, the halogen is going to be attached to, it's going to be attached to this carbon atom. तो ये बात समझ आइए कि they'll ask you a lot of questions कि भाई this thing is getting produced, so which halogenoalkane, or name the reagent, or draw the reagent, ठीक है, draw the skeletal formula of the reagent. Just make sure कि it's, if this thing is getting attached, then it's this carbon over here that was with the Cl, which made it positive. That's why it went over there and got attached. तो ये clear है बात?
यस सर।
अच्छा, so this is alkylation. Okay, there's another one which is known as acylation, which is very similar. So kind of exactly the same. It's so acylation is that that now what you have is you have a reaction with an acyl chloride. So it's a reaction with acyl chloride. So acyl chloride क्या होता है? It's a reaction with acyl chloride. And acyl chloride is this thing. It's a CH3. Well, not a CH3. It's I want to write the functional group. It's a I mean, this is the rest of the molecule. And C double bond O. And Cl. So this is what an acyl chloride is. ठीक है? It's a new functional group which we're going to study later as well, but that's what an acyl chloride looks like. तो उसके अंदर होता है कि you take a benzene, you react it with any acyl chloride. So for example, I reacted with CH3, then there's the CH2, and then there is acetyl bond ON and Cl. So there's one carbon over here that is extremely positive, and that carbon atom is this one. ठीक है? और what happens is कि this positive carbon atom gets attracted to the benzene, and the Cl will eventually get knocked out. ठीक है? So it's this carbon over here. Just go. I'm coloring it blue. It's this carbon over here that is the one that's going to get attached. तो ये बीच में से चीजें हटा देते हैं. और इसके अंदर भी the other product is going to be HCl. ठीक है? So this is where the benzene is going to join in, and HCl is going to be produced as well. I say HCl is going to be produced as well. So that's acylation. That's it. Or it's kind of you need a catalyst as well. That's AlCl3. So that basically summarizes electrophilic substitution, all of it. कि आपके पास so we did all of it. ठीक है? All of it is done. NC start कर लेते हैं. You've got acylation clear है सारों को? Sana, is this clear? Aseem, Umar, clear है?
Yes, sir.
Yes, sir.
अच्छा, अब इसमें ये कि अच्छा, तो ये acylation है, और बस वो जल्दी से एक दफा गो थ्रू कर लें कि you had alkylation, फिर हमने पढ़ा था कि we did C5 directing groups. You don't have to remember the conditions, but just remember that it's going to be very difficult. The reactions are going to be very slow, so you would need extreme conditions. So bromination and nitration will happen very, very slowly. ठीक है? But if it happens, it's going to happen at positions 3 and 5. Here we did phenols and phenylamine. I told you that over here the electron donating effect is very high, which means that the benzene electron density is extremely high. The reaction is very vigorous. So you don't even need any catalyst. You just need Br2 aqueous. That's the only condition that you require. And bromine gets attached to all three positions, or the chlorine gets attached to all three positions. Nitration में क्या होता है कि again the reaction is very vigorous. It happens with dilute nitric acid. It also happens with concentrated nitric acid. Dilute nitric acid में you get just one NO2. Concentrated के अंदर you get NO2s on all three positions. फिर arenes का था, they were also 246 directing, but the conditions were exactly the same. The electron donating effect was very slight. So it was also 246 directing, but they had the same conditions as benzene. ठीक है? और फिर finally you did the mechanism as well. ठीक है? वो याद रखना है. तो कि नाइट्रेशन में एग्जैक्टली होता क्या है. ठीक है? यू हैव टू रिमेम्बर एवरीथिंग. ठीक है? तो ये बस देख लेते हैं कि तुम खाली वही क्वेश्चंस करें पास where benzene is involved. अच्छा, यहाँ पे खुल गया. How you require a catalyst? It's ये मैंने लिखा था यहाँ पे. You need an AlCl3 catalyst for this. See, I think 30 marks होंगे organic. 25 to 30. Questions simple ही होंगे इतना भी. But as an example, वो कह रहे step 1 में conditions. Step 1 ये हमने किया था. If you look at step number 1, so remember the Cl is getting attached not to benzene, it's attached to a carbon chain. तो ये वो free radical substitution था alkanes का, alkyl chains का. So the first step is you need Cl2 plus UV light. ठीक है, ये हमने पहले पढ़ा था. इससे पहले जब हम एस की रिविजन कर रहे थे ना, I told you that if you want chlorine to get attached to the carbon chain, it's got to be, or any carbon chain or an alkane, or substitution, it's free radical substitution and it's with UV light. और फिर वो कह रहा है कि अब यहाँ पे ना ये saying कि chlorine gets attached onto the benzene. तो वो कह रहा है suggest reagents and conditions. For that it's going to be you would need Cl2, you would need FeCl3 or AlCl3 catalyst, और आपको ना बस यही दो चीजें चाहिए और तो कुछ नहीं चाहिए. कैटलिस्ट चाहिए. और खैर ये वाला पार्ट तो अभी किया वही नहीं है. विल जस्ट फोकस ऑन ये तो खैर मैं खाली उसके ऊपर फोकस करना चाह रहा हूँ. लीव दिस एज वेल. State the reagents and conditions needed to convert benzene to chlorobenzene. That's Cl2 plus AlCl3 catalyst, Br2 plus AlBr3 catalyst. Nitrobenzene, where you need concentrated nitric acid plus concentrated sulfuric acid, and the temperature has to be 55. और वो कह रहा है कि भाई वो show the mechanism. तो what's the mechanism? That the mechanism is going to be कि बीच में ना there's going to be this step where the benzene electron cloud will become partial. कि वो जो आपका electrophile वो NO2 plus 1 को ना and he's also asking what is A. A is actually NO2 plus 1. So they're going to ask you for the mechanism. Draw the structure of the intermediate in the box. We just did that. ठीक है, मतलब यही हमने mechanism draw किया था कि वो A आएगा, it's going to borrow electrons from the benzene and join with it, so it will become partial. ये वो आ गया कि वो कह रहा है कि NO2 remember is 3,5. He's saying draw the products. NO2 is 3,5. So इस केस पे it's the bromine is going to get attached to position number. It's going to get attached to positions number 3 and 5. ये clear है? ये भी 3,5 पढ़ा था. ये चीज clear है?
Yes, sir.
अच्छा, ये एक interesting question कर लेता हूँ कि what if a molecule has both groups 3,5 and 2,4,6? Like over here, NH2 is 2,4,6. NH2 is an electron donating group. ठीक है, it's got a lone pair, it pushes electrons. So what happens is that the electron density becomes higher on this side, positions number 2 and 6. 4 को हम ignore करें because there's already something attached to 4. So this is the one that directs it onto the 2,4,6 positions. This is the one that directs it onto the 3,5 position. अब दोनों के perspective से ना it's the same position. Like carboxylic acid directs it to the 3 and 5 position. तो यहाँ से अगर count करोगे, that's 1, 1, 2, and then 3. And this is 4 and this is 5. तो दोनों के perspective से it is the same position. These two carbon atoms, that means कि your chlorine is probably going to get attached to is going to get attached to this position. ये उसको 3 पे भेजेगा तो यहाँ से it's 1 2 3 this one. वो उसको 2 पे भेजेगा, that's only 1 and 2, so it's also the same one. Is this clear?
सर वो उसकी साइड से भी इस तरह से होगा।
क्या?
ये आपने जो क्लोरीन बताया कि मतलब कार्बोक्सिलिक एसिड से मतलब वो पोजीशन नंबर 3 पे जा रहा है और वहां से मतलब 2 पे जा रहा है, तो
ये
दूसरी
उसको
साइड से भी
ये
सेम ही
उसको
होगा
3
ना?
ये इसको 3 पे भेज रहा है, ठीक है। तो इसके पॉइंट ऑफ व्यू से 3 कौन सा है? वो ये वाली पोजीशन है ना, मतलब कार्बोक्सिलिक एसिड 3 पे भेजता है ना, 3 5 पोजीशन पे भेजता है ना। NH2 उसको 2 पे भेज रहा है, तो NH2 के पर्सपेक्टिव से 2 यही पोजीशन होगी, तो दोनों के पर्सपेक्टिव से वो वही पोजीशन आ रही है। ये क्लियर है?
यस सर।
अच्छा, और कोई इस तरह का वैसे वो कह रहा है व्हाट टाइप ऑफ रिएक्शन इज वन, तो ये फिनोल्स का है जिसके अंदर Cl आके अटैच हो गया, दैट्स इलेक्ट्रोफिलिक सब्स्टिट्यूशन। If you want to attach chlorine, you don't need a catalyst. Phenol is very activated. You don't. अच्छा, you don't.
सर
हाँ जी।
सर वो लास्ट वाला जो क्वेश्चन था ना सर, वो फिर से रिपीट कर सकते हैं सर?
नहीं, मैं कह रहा हूँ कार्बोक्सिलिक एसिड किधर भेजता है इलेक्ट्रोफाइल को? पोजीशन नंबर 3 पे भेजता है ना, तो इसके पॉइंट ऑफ व्यू से पोजीशन
सर
नंबर वो पोजीशन 3 पे भेजता है, इसके पॉइंट ऑफ व्यू से। माइक थोड़ा ऑफ करो। पोजीशन नंबर 3 ये वाली पोजीशन है। NH2 क्लोरीन को किधर भेजेगा? पोजीशन नंबर 2 पे भेजेगा, वो 2,4 डायरेक्टिंग ग्रुप है। उसके पॉइंट ऑफ व्यू से पोजीशन नंबर 2 कौन सी बनती है? वो भी वही बनती है। उसका मतलब क्लोरीन कहीं से भी आया वो इधर ही आएगा।
नहीं सर, मैं कह रहा था कि दूसरी साइड से भी एग्जैक्टली इस तरह से होगा ना, जो मतलब वो उस साइड से लेफ्ट से।
हाँ, मतलब तो वो तो एक ही बात होगी ना, वो तो इसको उल्टा करके रख दो बस, तो वो ये वाली पोजीशन बनेगी, वो भी सेम ही है ना। मतलब लेफ्ट पे जोड़ दो, यहाँ पे जोड़ दो बेशक, ठीक है। बस ये फिनोल्स का क्वेश्चन आ गया। फिनोल्स हाईली एक्टिवेटेड थे तो क्लोरीन एक्वस, यू डोंट नीड अ कैटलिस्ट, नथिंग। यू ऐड Cl2 aqueous 246, उसने तीसरे पे नहीं अटैच किया हुआ, लेकिन so what type of reaction is this? This is electrophilic substitution. बाकी उसको छोड़ दो, सिर्फ इलेक्ट्रोफिलिक सब्स्टिट्यूशन। चलो ठीक है, कल क्वेश्चंस करते हैं। और सो वी आर डन विद इलेक्ट्रोफिलिक सब्स्टिट्यूशन। ये मेजर क्वेश्चंस, मतलब एक क्वेश्चन तो कम से कम इसी पे आता है, इलेक्ट्रोफिलिक सब्स्टिट्यूशन। ये मैं भेज देता हूँ, ठीक है
सर वो कल वाली रिकॉर्डिंग भी।
ठीक है, ओके, हाफिज।